In this video, we're going to talk about Hall effect sensors from a practical working perspective. This is a Hall effect sensor, more commonly called a Hall sensor. But what are Hall sensors and what are they used for? Hall sensors are used to precisely track minute changes in magnetic flux density. Simply put, if we position the sensor within a magnetic field and vary its position, the sensor will provide an output voltage that can be precisely measured and fed into an electronic system. Hall sensors find applications everywhere in the modern world, including game controllers, engines, anti-lock brakes, electric motors, and tachometers. So for our demonstration, we will need both a Hall effect sensor and a magnetic field. The package of this Hall sensor, which refers to the component form and shape in electronics, is known as a TO92 UA. The TO92 package is very common and has this characteristic shape with a single line of 3 leads. The UA part tells us that it's an ultra-mini version. Being ultra-mini, it's small, really small. This scale gives you an idea of just how small it is. It has the number 503 branded on one side. This number identifies it as a particular type of Hall sensor, fully described in its datasheet. We're not going to describe it further, other than to identify each of its 3 leads. From left to right, they are supply voltage, ground, and output signal. Now let's connect some wires so that we can place it in a circuit for a practical demonstration of what it does. In this simple circuit, you can see that the ground lead of the sensor is connected to the black terminal of a power supply and to a multimeter. The positive terminal from the power supply provides 5 volts to the supply lead of the sensor. The signal lead of the sensor is connected to the positive probe of the multimeter. Now, let's create our moving magnetic field. For our magnetic field, we're going to use these 2 small neodymium magnets. We're going to place them in a 3D printed holder that I designed and made earlier. The orientation of the magnetic poles, from left to right, is north, south, north, south. Now we're ready for our demonstration. As you can see, rotating our magnetic field around the sensor results in the voltage output signal varying from high to low. This is the working principle of a Hall effect sensor. In a future video, we will integrate the Hall effect principle with the TechTalk English special project. The output signal from this sensor will be fed into an Arduino microcontroller, interfacing it with a PC. Hall effect sensor. Magnetic flux density. Package, datasheet, multimeter, neodymium magnet,